All right, guys, today we're going to jump in with some function operations here. And for our warm-up question, I would like you to evaluate these two functions. So for the first one, you need to do f of 3. And the second one, you need to do g of -2. So for the answers to this, on the first one, all we're going to do is replace all of the x's here in f of x with 3. So this becomes f of 3 equals 3 squared minus 3 times 3 plus 7. We then just evaluate using order of operations. We get 9 minus 9 plus 7, which is 7. For the next one, g of -2, we're going to replace all the x's there in g with -2. So 3 times -2 to the third power plus -2. We want to do that exponent first. -2 to the third power is -2 times -2 times -2. So we get -2 times -2 is 4, times -2 again is -8. 3 times -8 turns to -2, which is -24 minus 2, which is -26. So hopefully you got a good grasp on that. That is something that you've seen before, and we're going to apply these properties to what we're going to be doing today, which is function operations. Specifically, we're going to be adding, subtracting, multiplying, and dividing functions. These functions could be polynomials, like these last two. They could be square roots. Theoretically, they could also be what we call rational functions, or functions that are fractions. But in addition to adding, subtracting, multiplying, and dividing, we're also going to be plugging in some numbers like we did on these as well. It's called evaluating the functions. So let's go ahead and get started. The first thing to note is that functions behave a lot like any real number. So real numbers, you can add them. Real numbers, you can subtract, multiply, and divide. Functions are very much the same. You can do those exact same operations. So if a sum, we're talking about a sum, that means addition. The notation is the only thing that's going to look a little bit different. So this is what we call function notation for a sum. Looks like this, f plus g of x. That's how we pronounce f plus g of x. Remember when it has this little x in parentheses, we say of x. That's the same thing as actually writing it as f of x plus g of x. It's exactly the same thing. When we talk about a difference, meaning subtraction, it's going to be written like this, f minus g of x, or it could be g minus f of x. That's the same thing as saying f of x minus g of x. So don't let the notation bog you down. For a product, that means multiplication. We're going to use a little dot there. This would be pronounced f times g of x. And again, it's equivalent to f of x times g of x. And lastly, for a quotient, we're going to write like this, kind of like a fraction. But remember, all fractions are also division. So f over g of x, or f divided by g of x, would be the same thing as writing this as a fraction, f of x over g of x. So really the only thing new there is some notation. So let's jump into solving a few of these. We'll start with a basic one, f plus g of x, and we're going to be using these two functions. If you need to pause and jot them down, do so. Remember, this is the same thing as f of x plus g of x from that notation we just talked about. So all we're going to do is take our two functions and add them together. It's a good idea. You don't have to do this, especially with additions when we get started here, but it's a good idea to write the whole function in parentheses. So all of f of x I write in parentheses plus all of g of x, which is -3x plus 7. Write both of those in parentheses. Now in this case with addition, you can just ignore the parentheses because there's no number to distribute in or anything like that. But it's just a good habit to do, which you'll see on the next one as well. All right, so then we're just going to basically evaluate this. Again, we can ignore the parentheses, and we're going to identify like terms. Well, we've got a 5x here and a -3x. And if you even want to group those, you can. You don't need to do this, but if you want to, you can. Group those together, so 5x minus 3x. And then we've got like terms here, -2 and 7. So then minus 2 plus 7. And we just combine those. 5x minus 3x is 2x. And negative 2 plus 7 is 5. So that's going to be our answer. 2x plus 5. For the next one, it looks pretty similar. It's f minus g, but instead of x, it's actually f minus g of 3. Now there's a couple ways you can do this. If we use that same notation that we just talked about, where we write it in this way here, if we were to write this in that same way, it would actually be, let me change colors here real quick. It would be actually the same thing as saying f of 3 minus g of 3. Right? If we take that same logic and just we have a 3 in there instead of an x. So what this is saying is if we just turn back to our warm-up question, there where we had f of 3's and g of negative 2 in this case, well, we actually just plugged it in. So that's what we're going to do. We're just going to plug it in, and then we're just going to add or subtract. Or we're just going to do it twice. So f of 3 means I'm just going to plug 3 into f of x. So 5 times 3 minus 2. And I'm going to put this whole thing in parentheses. Minus, parentheses, g of 3. So then negative 3 minus 3 plus 7. So then I just look at this as kind of two separate problems, and at the end I'm going to subtract them. So with this first one, it becomes 15 minus 2, which is 13. And I can go ahead and drop the parentheses there. Minus, we get negative 9. Negative 3 times 3 is negative 9 plus 7, which is negative 2. So minus negative 2. The minus minus becomes a plus, so it becomes 13 plus 2, which is 15. So as a general rule, if you plug a number in, then your final answer is going to be a number. If you plug an x in, your final answer is probably going to have x's in it. So let's look at a multiplication and division one here. For multiplication, parentheses are definitely very important in this case. Remember, this is the same thing as f of x times g of x, right? So f of x, right, in parentheses would be 5x minus 2. And then I'm just going to, you can write the multiplication sign there if you want to, but in general, at this point in math, you just write parentheses instead of writing that sign. So you would just write it as parentheses negative 3x plus 7, and given that there's no sign there, those parentheses mean multiplication. All right, so from this point, hopefully you can think back to last year or the year before. Think about what we need to do here. These are called binomials, meaning there's two terms. When you multiply these binomials, you have to do something called FOIL, or really just the distributive property, but it gets this term called FOIL, which I'm sure you've heard at some point. FOIL stands for first, outer, inner, last. So you multiply the first terms, 5x times negative 3x. That gives you negative 15x squared. Then you do 5x times 7. That gives you 35x plus 35x. We then do negative 2 times negative 3x. That gives you a positive 6x. And then negative 2 times 7, which is negative 14. We then combine our middle terms there, because they're like terms. So we get negative 15x squared. That becomes plus 41x minus 14. And that's our final answer, because there's nothing else we can combine. There's no other like terms or anything. So that is going to be our answer. All right, now the next one is a division. And again, this one has a number here. So we're going to write this as f of 1 over g of 1. In the same way that if it was an x. So then we're just going to plug 1 into f. So that becomes 5 times 1 minus 2 over negative 3 times 1 plus 7. 5 times 1 is 5, minus 2 would give you 3. On the bottom, negative 3 plus 7, which is 4. So 3/4, that's our answer. Okay, let's go ahead and look at the next one. This time we're going to switch it up. We're going to plug a number into the +1 and then do the x for the minus. Why don't you go ahead and try that one? All right, so for this first one, this is the same thing as f of 4 plus g of 4, which means it's the same thing as saying 4 squared plus 3, that's plugging 4 into f, plus 3 times 4 to the third power plus 4. We're going to replace all of the x's with those. I know there's a lot of parentheses going on, but just hang with me here. So 4 squared is 16. 16 plus 3 is 19. So we have 19 for our first one, plus, it's a little bit more challenging here, but 4 cubed is 4 times 4 is 16, times 4 again is 64. 64 times 3, do that in your head, it's 192. 192 plus 4 is a 196. Add those together, that gives you 215. All right, next one, again, we can write this as f of x minus g of x. It is helpful to do this on all of them, or just to rewrite it, I think. So you at least are a little bit more well set up for success with your structure. So in this one, it's going to be x squared plus 3. Parentheses are really important in this one, minus 3x cubed plus x. The reason why parentheses are important is if you didn't put the parentheses, then you would probably just apply that negative sign to the first term, but this actually has to get distributed to both of those terms. So I'm actually going to go ahead and rewrite this. X squared plus 3 minus 3x cubed, and then we got to distribute that negative as well, so it's minus x. So then from this point, I'm just going to combine like terms if I have any. If not, I'm just going to rearrange it and write it in order from the highest power to the lowest power. And you can see there's no other x squareds, there's no other constants, no other x cubes, no other x to the first power. So I'm just going to rearrange this and write it as minus 3x cubed plus x squared minus x plus 3. So that it's in order, we call it descending powers, highest power to the lowest power. Okay, the next one, go ahead and give this one a shot. So f times g of 2, this is the same thing as saying f of 2 times g of 2. So f of 2 would be 2 squared plus 3, put it in parentheses there, times 3 times 2 cubed plus 2. Replace all of the x's with 2. From there, we've got 2 squared is 4 plus 3 is 7. 7 times 2 cubed is 8. 8 times 3 is 24, plus 2 is 26. 7 times 26, 20 times 7 is 140. 6 times 7 is 42, so it'd be 182. All right, the next one is f over g of x. For this one, again, it's helpful to go ahead and write it as f of x over g of x. F of x is x squared plus 3. G of x is 3x cubed plus x. Now with this one, you might be thinking, man, what can I do at this point? Well, the good news is you don't really have to do a lot of anything else. Technically, if there was something we could factor out and cancel, we would want to do that. Like if there was an x we could pull out and cancel, we'd want to. This one doesn't have anything that we can cancel, so we're just going to leave it as written, x squared plus 3 over 3x cubed plus x. Pretty simple. All right, we've got one more set of examples here. This one is going to have the square root function. So in our first one, Again, let's go ahead and write this as f of x plus g of x. And that would just become the square root of x plus 2x plus 7. Parentheses aren't really necessary in this one because it's just addition. And there isn't anything that you can actually combine on this either. There's no like terms because you can't combine a square root of an x with an x to the first power. If you remember, the square root of x is actually x to the 1/2 power. This is the technical exponent as what we call a rational exponent. But don't remember that, no worries. I am going to just write these out. I'm going to put the 2x first because, again, x to the first power is actually a higher power, and then plus the square root of x, and then plus 7. And again, the reasoning behind that is if you remember, at some point in Algebra 2, hopefully you did what was called rational exponents, which is turning this into, this would actually be a 1/2 power. Would be another way of writing it. You don't need to do that, but I'm just want you to think of that when you're ordering your power. So you got an x to the first power and then x to the 1/2 power, and then you have no x's. So you can view it in that way. All right, the next one, go ahead and try it. F of 4 minus g of 4. We get the square root of 4 minus, parentheses, 2 times 4 plus 7. So the square root of 4 is 2, minus 2 times 4 is 8, plus 7 is 15. So 2 minus 15, which is negative 13. All right, and then let's wrap it up with a multiplication one. So remember, this is the same thing as f of x times g of x. You could also even just write it like this, f of x, g of x. That implies multiplication. So this is going to be the square root of x times 2x plus 7. All right, now this one, I do want you to think back about rational exponents. If you missed this one, not the end of the world, but I do want you to think about how we would do this with rational exponents. So as I just told you on the previous slide, this square root is the same thing as a 1/2 power, right? And technically what we're supposed to do here, this is multiplication, so we have to distribute this to both of these terms. Now what we don't want to do is just write it as like square root of x 2x. That doesn't look so good, right? Not a good way to do that. So what we're actually going to do is think of these as rational exponents, x to the 1/2 power times 2x plus 7. And remember, there's an invisible 1 up here. So when we multiply this, when you multiply, think about what you do with exponents. You add the exponents. So this becomes 2x, and then, because we have 2 in front, the 1/2 plus 1 power plus 7x to the 1/2. Now we obviously want to simplify that. 1/2 plus 1 would be 1/2 plus 2/2, so there'd be 3/2. So 2x to the 3/2 power plus 7x to the 1/2 power. It's okay if you want to leave it like this. This would be as a rational exponent. You could also rewrite this as 2. And then if you remember, in this fraction, the top number is the power. So it would be x cubed. And then the bottom we say is the root, or the root index. So this would actually be 2 radical x cubed is how you would write that. Again, don't get too concerned if you can't do that at this point. But that is how you'd write that in what we call root form, plus 7, and then x to the 1/2 power, that's the same thing as the square root of x. So that would be, I guess you could say, the best way of writing that answer. All right, and last one here, go ahead and try that. So this is f of 2 over g of 2. F of 2 would be the square root of 2 over 2 times 2 plus 7. So we get radical 2 over 4 plus 7 is 11. And that's fine to just leave it like that. All right, finish up with a got it question here. Go ahead and give these two a shot. For our first one, f of x plus g of x. is going to be 4x plus 5 plus x minus 4x squared. Identifying your like terms here and combining. You've got x's and x's. So we get negative 4x squared comes out in front because it's the highest power. 4x plus x is 5x, and then plus 5, the first one. And the next one, this is the same thing as f of 2 times g of 2. So this would be 4 times 2 plus 5 times 2 minus 4 times 2 squared. That gives us 8 plus 5, which is 13, times 2 minus 2 squared is 4 times 4 is 16. So 2 minus 16, which is negative 14. 13 times negative 14 is 182, negative 182.